for this data sufficiency question, I'm going to spare you the algebraic solution, which you can find easily by Googling it. And I'm just going to give you a way to think about this by reasoning. So what they're asking is, what happens to the ratio x over y when we increase both the top and the bottom by 1? In other words, we're mixing two ratios here, a ratio of x to y with a ratio of 1 to 1. And we're adding 1 to 1 to x to y. And the question is, does that increase or decrease that original ratio of x to y? Because they're asking, is x plus 1 over y plus 1 greater than x over y? So they're asking, is this mixture of two ratios, again, those two ratios are x to y and 1 to 1, when we mix those together, does the overall mixture lie somewhere to the right of x over y? We don't have any free info here, but when I look at the statements, I do notice something interesting, which is that if we know statement 1, we can infer statement 2. Isn't that right? I mean, statement 1 implies that both x and y are positive, and if both x and y are positive, then of course their product is positive. So knowing statement 1 implies statement 2, which means that we can eliminate answer choices B and C without even reading the question. I explain the reasoning for that in the second section of my book, which you can actually read for free on quantreasoning.com. So we're down to three answer choices now, A, D, or E. And I think I'll start with statement 2, because statement 2 seems a bit simpler. It's just saying that x and y are both on the same side of 0. Now, if I know that they're both on the same side of 0, does that allow me to infer where the mixture of x to y and 1 to 1 would fall? Like, would that mixture fall to the right of x over y, or would it not fall to the right of x over y? And what I'm realizing there is that even if I knew for sure that x and y are both positive, I still could get the mixture of x to y and 1 to 1 on either side, because if x over y lies between 0 and 1, and I know where 1 to 1 lies, 1 to 1 lies exactly at 1, the mixture would be somewhere in between them, which means that I get, yes, it is to the right of x over y. On the other hand, if x over y is to the right of 1, which would happen if they're both positive and x is greater than y, or if they're both negative and x is less than y. So there are different ways that we can make this happen, but statement 2 certainly allows for the possibility that x over y is to the right of 1, and again the mixture would lie somewhere in between 1 and x over y, except this time that leads to a no, because the mixture, the x plus 1 over y plus 1, would be to the left of x over y. So statement 2 is not sufficient on its own, which means we can also eliminate D. We're down to two answer choices, A or E. Now, taking what statement 1 told us, we can confidently place the ratio x over y somewhere in between 0 and 1 on the number line. We're looking at a proper fraction here, a fraction that's less than 1, a positive fraction that's less than 1. When you mix that ratio with a ratio of 1 to 1, the mixture will definitely lie somewhere in between x over y and 1, and that means that it's definitely going to be to the right of x over y, giving us a definitive yes. And therefore the correct answer here is A. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.